You're in the final round of a cloud architect interview. The panel asks how you'd secure a new environment. For many candidates, this triggers a sudden panicked instinct to start rattling off an alphabet soup of services. Listing isolated terms like WAF, IAM, and EC2 might prove you've seen a dashboard, but it fails the interviewer's real test. They aren't looking for a glossary of software. They want to see if you can apply a consistent architectural methodology. They are evaluating your high-level design logic, not your ability to memorize an operational vocabulary. This diagram illustrates a structural framework that organizes that complexity into 3 core pillars: identity, infrastructure, and the pipeline. Pillar 1 is identity and secrets. This determines how every user and service authenticates within your cloud fabric. Pillar 2 covers infrastructure, where you establish network isolation and your compliance baselines. Pillar 3 is the CI/CD pipeline, where you automate security checks before any code is actually deployed. Anchoring your answer to these 3 pillars allows you to handle a sudden pivot to a multi-cloud context. It provides the structure needed to organize specific vendor services into their correct functional buckets. Modern identity architecture starts with a single principle: the complete elimination of long-lived, hard-coded credentials. In AWS, we replace static API keys with IAM roles assigned directly to instances, allowing machines to authenticate themselves. Azure uses managed identities, integrating with Key Vault to securely pull passwords only when the application needs them. Applications authenticate natively within the cloud fabric. No secrets are exposed in the codebase, and no developer ever has to handle a raw key. This approach adds significant upfront complexity. Building these abstracted identities takes far more time than simply passing a password as an environment variable. It requires strict RBAC policies. You must disable public storage access, relying on SAS tokens to grant restricted access to untrusted third parties. Prioritizing this foundational identity abstraction proves to the interviewer that you value long-term security over the convenience of hard-coded secrets. Moving to the infrastructure pillar, you must solve for 2 things: strict network isolation and continuous configuration monitoring. This map illustrates the isolation strategy. Public access is blocked at the perimeter, forcing traffic through private endpoints. This strict isolation makes debugging difficult, as developers lose standard SSH access. To regain it, you implement a dedicated bastion host, creating a controlled secondary tunnel. Even a locked network is vulnerable if internal changes go unmonitored. This is configuration drift, when an admin manually opens a port, violating your baseline. AWS config and Azure policies act as continuous monitors, scanning every live resource against an approved baseline image. The moment a port is opened or an encryption setting is changed, the system detects the deviation. However, these tools often lead to alert fatigue. If they only generate emails, teams stop reading them. The solution is automated remediation. If a resource becomes non-compliant, a function triggers to instantly shut it down or revert the change. Automated remediation ensures your environment maintains its own integrity, regardless of human error or manual drift. The final step is shifting security left. By the time a vulnerability reaches the cloud, it's too late. It must be stopped in the pipeline. You achieve this by centralizing your deployment logic into reusable workflow templates. When every development team uses these shared templates, they automatically inherit your mandatory security checks. The trade-off is team autonomy. Centralizing these workflows reduces the ability of individual squads to customize their own unique deployment paths. This flowchart shows the automated gatekeepers in action. Every code commit must pass through scanning notes like checkoff and trivy. If a developer accidentally opens permissions too wide, the pipeline actively blocks the build from progressing. Pipeline automation transforms security from a manual human bottleneck into a scalable, engineering-driven practice. The overall strategy for your interview is now clear: lock down the identity, isolate the network, and enforce roles through the pipeline. Now, you must tailor this answer based on the role you are targeting. For SRE and DevOps roles, the scorecard looks like this. You should focus your answer heavily on Pillar 3, emphasizing your expertise in YAML templates and automated spanning. If the role is for a cloud architect, shift your focus to the technical parallels between AWS and Azure services in Pillars 1 and 2. This approach requires you to deeply understand the equivalent services across both major cloud providers. It is a significant investment in time. This type of cross-platform expertise takes far more preparation than just learning the UI of a single provider. This three-pillar platform-agnostic framework gives you control over the narrative. It demonstrates the high-level design thinking expected of a systems architect.